Faraday's laws of electromagnetic induction. In 1820, Orested discovered that when a current is passed through a wire, a magnetic field is produced around the wire. After this discovery, scientists began to search for the reverse phenomenon, that is, conversion of magnetism into electricity. In 1831, Faraday demonstrated that electric current can be produced in a wire by the magnetic field. Now let us look at Faraday's experiment. The experimental arrangement made by Faraday is shown in figure. A coil consisting of a few turns is joined to a sensitive galvanometer, which detects the current. Then the following experiments are performed with a magnet. Faraday found that when the magnet is moved toward the coil, the galvanometer shows a deflection. This deflection in the galvanometer can be observed as long as the magnet remains in motion. When the magnet is moved in the opposite direction, the galvanometer changes the direction of deflection. When the magnet is moved quickly, the deflection in the galvanometer increases. When the coil is moved and the magnet is kept fixed, similar results were obtained. The deflection of the galvanometer is only due to some current flowing in the circuit. The current that flows in such a circuit is called induced current. Students, this phenomenon of evolution of electricity from magnetism is called electromagnetic induction. Here is the explanation. The total number of magnetic lines of force due to the magnet passing through the coil doesn't change when the magnet and the coil are relatively at rest. But when the magnet is moved or the coil is moved, there is a change in the magnetic lines of force. This causes the flow of electric current in the circuit. The electric current produced due to the change of magnetic lines of force in a closed circuit is called induced current. Dear students, now let us study about Faraday's laws of electromagnetic induction on the basis of the above experiment. Number 1. Whenever there is change in number of magnetic lines of force through a coil, an electromotive force is induced due to which current is induced. Number 2. The magnitude of the electromotive force induced is directly proportional to the rate of change of magnetic lines of force. Students, now let us look at this activity. Wrap about 100 to 150 turns of insulated wire around a rectangular matchbox. Leave two ends of the wire exposed and connect them to the ends of a galvanometer. Take a powerful magnet and take it inside and outside of the matchbox rapidly. Observe the motion of the needle of galvanometer. Why does the needle of the galvanometer deflect? Fleming's right-hand rule. Students, we have seen that in the electromagnetic induction, current is induced in the conductor. The direction of the induced current can be found by the Fleming's right-hand rule. Stretch the thumb, central finger and forefinger of your right hand mutually perpendicular to each other as shown in the figure. If the forefinger indicates the direction of magnetic field, the thumb in the direction of motion of the conductor, then the central finger gives the direction of induced current in the conductor. Here's a note. The M from the thumb stands for motion of the conductor. The forefinger's F stands for field, and the C from the central finger stands for current induced.